Stars, just like human beings, have a lifetime. They are subject to the relentless march of time. It's about to explode.
No, give me the timescale for that.
The thing is, it could be tomorrow. It could be during this broadcast, and it would shine like a second sun in the sky because it's only 600 light years away.
The expansive and complex universe consists of billions of galaxies, each filled with millions of stars that illuminate the cosmos and shape the fabric of space-time. Yet minutes ago, over 700 trillion stars have completely disappeared, shaking the very foundation of our universe. Normally, we expect the sky to sparkle with stars and galaxies when we look up. However, everything is now exploding out of control, leaving only total darkness where stars once illuminated the night. Is there any way to detect this? Let's find the answers to prevent our planet from becoming the next victim of an unpredictable supernova. The stars suddenly disappeared without a trace. Into this cryptic and confusing scenario stepped a dedicated team of astronomers. This mission, known as the Vasco project, is more than just an academic pursuit. It represents a profound shift in how we understand the cosmos mechanics. Led by Beatrice Vell from the Nordic Institute for Theoretical Physics, this team is driven by a deep curiosity about the universe and the exciting potential to rewrite the history of astronomy. This team's trip is fueled by the desire to understand these vanishing stars, an endeavor filled with as much uncertainty as it is with determination. As they sift through their data, they confront the possibility that the familiar twinkling stars could be more ephemeral than we ever imagined. This inquiry is not just about collecting data, it's about challenging the very foundations of celestial mechanics and potentially discovering new phenomena that could change our understanding of the universe. The story we're discussing might seem absurd to some. The idea of stars simply disappearing from the sky. Many would laugh it off as ridiculous with a quick dismissal. However, the universe doesn't have to make sense based on our limited human expectations or align with the slow passing of time as we understand it. Supernovae, those brilliant explosions that mark the death of enormous stars, are well-known and dramatic cosmic events. They light up the heavens, marking the conclusion of life cycles of some of the most massive stars known. Such events are documented extensively and are quite the spectacle, but they don't explain the quieter, more cryptic disappearances of stars that the Vasco project is trying to figure out. Is it possible that we are on the cusp of discovering something completely new to science? Are we being fooled by some cosmic illusion, a mere trick of light and darkness on an unimaginable scale? The stakes are incredibly high. This research could potentially overturn long-standing scientific ideas or pave the way for new theories to emerge from the ruins of the old ones. This quest has gathered a varied group of researchers ranging from experts in star physics to those passionate about the search for extraterrestrial intelligence. However, the task they face is incredibly challenging. Imagine trying to locate a single star that has consistently been visible in the sky until it wasn't, completely disappearing without any trace. It's like searching for a tiny needle in an immense, ever-expanding haystack. Every scientist involved in this project brings their own unique perspective, each hoping to uncover the reasons behind these cryptic disappearances of stars. They pool their knowledge and skills together, fully aware that the road to new scientific discoveries is often paved with more questions than definitive answers. The potential to either discover a completely new cosmic phenomenon or to debunk a possible grand illusion in space fuels their passion and drives their research forward. That mix of intense curiosities, specialized knowledge, and the excitement of the hunt defines their collective trip into the unknown parts of space. As they explore this enigma, they face the immense scale of the universe, as well as the limitations imposed by their scientific instruments and existing theories. Day after day, they search for that elusive star, the one that could potentially overturn everything we currently understand about the cosmos. The universe playing its tricks on us might just have thrown a new challenge our way. Now it's up to these scientists to decide whether to back down or continue playing the game, to write off the missing stars as mere data errors, or to see them as hints to a larger puzzle in our understanding of the universe. This trip isn't just about mapping stars or tracking celestial patterns. It's a profound quest that could reshape our understanding of our place in the universe. It serves as a reminder that the universe doesn't exist to be easily understood or to conform to our expectations. This exploration might not only redefine humanity's view of its position in the cosmos, but also reinforce the notion that the universe is vast, cryptic, and operates on its own terms, often eluding our grasp of comprehension. For these scientists, every unexplained star, every piece of unusual data is a call to adventure, an invitation to delve deeper and to think bigger about the cosmos. Now let's dive deeper into why some stars stop shining so suddenly, exploring the night with powerful telescopes to find lost stars. The night sky is like a vast painting filled with stars that blink and twinkle as they perform their cosmic dance. However, as Vell from the Vasco project would explain, this spectacle is more than just a regular cycle of celestial movements. Hidden among these stars are some that are preparing for a dramatic disappearance, challenging the usual slow-paced changes we expect in astronomy and pushing us towards discovering new laws of physics. Indeed, the universe contains many stars that change in brightness over just a few years. However, the goal of the Vasco project is to capture something even more extraordinary, a star that goes from being a consistent and reliable light in the sky to completely vanishing without any explosive spectacle like a supernova. This kind of disappearance could signal a major shift in our understanding of the universe. We are now in a time when advancements in telescope technology have dramatically changed how we observe the sky. The Samuel Oschin telescope at Mount Palomar, enhanced with the advanced Zwicky Transient Facility camera, is a prime example of these technological leaps. This powerful combination allows astronomers to scan the entire Milky Way twice every night, covering the whole sky visible from Palomar within just 3 days due to the camera's extremely wide field of view. This quick and thorough scanning significantly boosts the chances of detecting brief and dramatic cosmic events, like sudden bursts of light from distant stars, intense flares, or rare and powerful occurrences such as gamma-ray bursts. These innovations in telescopic technology have opened new doors in the field of astronomy, enabling us to monitor the heavens more closely and frequently than ever before. This heightened surveillance allows astronomers to catch fleeting astronomical events that were once too quick or too subtle to detect. Each night, as the telescope and camera comb through the vast stretches of space, they gather crucial data that could lead to the discovery of star behaviors that defy current astronomical theories. The Vasco project, with its focus on stars that simply disappear, challenges long-held notions about the stability and permanence of stars and suggests that our cosmic neighborhood is more dynamic and unpredictable than previously thought. While modern projects like the Zwicky Transient Facility are excellent at capturing images of brief and rare cosmic events, the main focus of the Vasco project is something more elusive, a star that suddenly vanishes. To study such a rare occurrence, which might happen only once in a century, you need a very long-term view of the sky, If you're chasing a phenomenon that occurs once every century, you need a long lens on history, says Vell, emphasizing the importance of combining modern technology with historical records. This need for a broad historical perspective has ironically brought the team back to the Samuel Oschin telescope at Palomar, which has been observing the sky for decades. Back in the 1950s, this telescope gathered extensive data for the United States Naval Observatory by capturing images of the entire sky on photographic plates. These old plates have been converted into digital form, creating a vital bridge linking past observations with current ones. This connection is crucial for comparing and understanding changes in the night sky over many years. But the Vasco team doesn't rely solely on old data. They also use cutting-edge tools like the Pan-STARRS at Hawaii's Haleakala Observatory and the European Space Agency's Gaia mission. Gaia is particularly impressive as it is currently mapping more than 1 billion stars in the Milky Way with incredible accuracy. This mix of old and new data gives the team a comprehensive view of the stars, allowing them to meticulously check each star that might have appeared or disappeared from the records. They carefully examine the old photographic plates and modern digital data for any signs of errors or inconsistencies that could suggest a star's unexpected disappearance or appearance. What occurs when a star that is expected to be in the night sky suddenly disappears? Each case where this seems to have happened is subjected to thorough scrutiny. Scientists compare the star's shape, brightness, and other key characteristics across different datasets to figure out whether the star really vanished or if the absence is just a mistake in the old data. This process is extremely detailed and can often feel repetitive and slow, but it's crucial for ensuring accuracy. For every star that appears to be missing, the verification involves cross-checking with both historical records and current observations. Astronomers look at images and data taken over many years or even decades to see if there are any discrepancies that might suggest a star has actually gone missing. They carefully analyze every piece of evidence, considering factors like whether the equipment used to gather old data might have malfunctioned or if newer technology might show something the old one missed. This painstaking process is necessary because the implications of finding a genuinely vanished star are profound. Such a discovery could challenge existing theories about star life cycles and the stability of celestial objects. It might lead us to reconsider some of the foundational principles of astrophysics and could even lead to new theories about how the universe works. Additionally, this rigorous approach helps scientists avoid false alarms, instances where it initially seems like a star has disappeared, but further investigation reveals it was just an error in how the data was recorded or processed. By verifying each potential case of a missing star with such care, astronomers ensure that any claims of a star's disappearance are supported by solid, reliable evidence. With new tools, we look closer at how we explore enigmatic star behaviors. Investigating the rapid loss of 800 candidates in space, the skeptical tone used here is quite justified. Discovering a star that has consistently been visible only to suddenly vanish is both disturbing and intriguing. It calls into question the foundational principles of our understanding of the cosmos. It suggests that maybe, in the massive, still largely unexplored areas of the universe, stars can actually vanish without any trace. This work, which bridges historical data with modern observations and balances between hopeful exploration and the stark realization of seeing an empty space where a star once was, is not merely about locating stars. Rather, it's about deciphering the enigmas they leave behind when they disappear. In the vast inventory of celestial events, astronomers have identified over 800 stars that seem to have enigmatically vanished. However, before we get carried away with ideas of stars disappearing into the cosmos and ushering in new scientific discoveries, we should remain grounded. A good amount of skepticism is necessary. Many of these stars are yet to undergo thorough examination, involving careful data processing and in-depth analysis. This critical step is essential to ensure that what seems like a star's disappearance is not simply an error or a misinterpretation of the data. Each of these potential disappearances must be methodically checked to confirm their authenticity. Also, scientists meticulously analyze variations in light and other data collected over time to ascertain whether these stars might have dimmed out of sight due to natural cosmic phenomena, or if they truly no longer exist. This investigation extends beyond merely noting their absence. It involves a deep dive into understanding why these stars might have vanished, exploring everything from black holes swallowing stars to new, unknown cosmic behaviors. This careful, methodical scrutiny is crucial because the implications of a true star disappearance are profound. Such an event could redefine existing concepts of celestial stability and life cycle. Moreover, proving a star's disappearance could lead to revolutionary changes in how we perceive the universe and our place within it. Thus, while the task of confirming these vanishings is arduous and filled with technical challenges, the potential to fundamentally transform our cosmic perspective drives the scientific community forward. In the fascinating field of astronomy, some recent studies have examined unusual cosmic events called transients, which have challenged our initial theories. These are not the intense flares typically seen in faint red dwarf stars, which are caused by complex magnetic fields, nor do they resemble the dramatic explosions known as supernovae. Instead, these transients form the bulk of our recent discoveries and present a complex puzzle that we are still trying to understand. They exist at the edge of our current astronomical knowledge, eluding easy categorization or explanation. As we investigate further, the complexity of these celestial phenomena only deepens. Less common types of stars like variable stars, cataclysmic variables, or novae, which involve explosions on the surfaces of white dwarf stars within binary star systems, do not completely match the characteristics we're observing. Typically, these explosive events happen near variable stars that are already known, and with the sensitive instruments we use today, we can usually detect a companion star to the white dwarf, even if the white dwarf itself cannot be seen. However, the transient cosmic events we're studying vanish as quickly as they appear. They might be the optical remnants following gamma-ray bursts or fast radio bursts, which are powerful bursts of energy from space. Despite their intense initial appearances, these bursts fade rapidly, leaving no lingering evidence that can be detected in later observations with even the most powerful telescopes. These phenomena challenge our understanding because they don't follow the expected patterns of other well-studied celestial events. Modern astronomical surveys designed to pick up faint stars and other celestial bodies should easily track these events and their related stars, but these particular bursts of energy seem to slip through, evading our detection methods following their initial appearance. This elusive nature raises intriguing questions about the nature of these cosmic events and suggests that there might be new, unknown processes at work in the universe which could open up new areas of research and might require us to rethink some of our current theories about how the universe behaves. With a pool of 800 candidates to evaluate, the variety and complexity of the scenarios are immense. Should we discover a perfect example of a vanishing star within this broad and diverse group? What sort of explanations might we imagine? One possibility to consider is a failed supernova, a situation where a very large star's center collapses into a black hole, which then consumes the star's external layers, leaving behind no evidence of the spectacular explosions typically seen in other supernovas. However, according to the researcher named Vell, the chance of witnessing such an uncommon event, predicted to happen only once every 300 years within our Milky Way galaxy, is quite low, making it unlikely for the Vasco projects to observe such a phenomenon. The search for a star that disappears without any remnants tests the limits of what we currently understand about space science. Some researchers from the Search for Extraterrestrial Intelligence suggest that the cryptic disappearances of these stars could more plausibly be signs of highly advanced extraterrestrial technologies rather than the conventional radio signals that have been the focus of searches in the past. This idea is consistent with the third law stated by Arthur C. Clarke, which proposes that any technology that is sufficiently advanced is indistinguishable from what might be considered magic. Next, we consider what these strange star behaviors could really mean for our universe. Are aliens rearranging our stars? The concept of constructing a celestial structure, such as a Dyson sphere, a theoretical massive construction that gathers the energy of a star, illustrates this idea. It implies that if a society progresses sufficiently, it could alter stars in ways that challenge our present comprehension, appearing as vanishing stars or other cryptic occurrences. Therefore, while the enchanting idea of finding vanishing stars captures our imagination, the pursuit is filled with more questions than answers. Each star we study might either transform our understanding of the universe or lead us down a puzzling path into the unknown. This exploration is as intimidating as it is thrilling, but as we stand on the edge of possibly monumental discoveries, one has to ponder, are we just chasing illusions, or are we close to revealing new aspects of physics? Only continued dedication and relentless exploration will reveal the truth. Each observation and experiment, while possibly leading to more uncertainties, also holds the promise of significant breakthroughs in our understanding of space and time. Thus, our trip through the cosmos is not only a testament to human curiosity, but also a significant stride towards unraveling the deeper laws of physics. Are we merely witnesses to the quirks of the universe, or pioneers on the brink of new scientific revolutions? As we continue our meticulous investigations, the answers to these profound questions will gradually come into clearer view, guided by the unwavering pursuit of knowledge. Imagine a situation where stars begin to disappear from the night sky, and there are no natural explanations that make sense. It's then very tempting to consider the idea of alien interventions or even supernatural forces being involved. Well, who leads the Vasco project entertains such thoughts, suggesting that perhaps constructions like a Dyson sphere or other impressive cosmic structures might be blocking our view of these stars intermittently. Or, in a more unsettling thought, perhaps advanced civilizations have figured out ways to remove stars that are in the way of their space travel paths. For each red transient star that the Vasco team records, the idea that it might have been caused by artificial means becomes a strong possibility. Although the standard approach is to look for natural explanations, the possibility of extraterrestrial involvement remains open and is quite intriguing. Could it be that a far-off civilization possesses technology so advanced that it appears to us as flashes of red light in our telescopes, mimicking natural space events? While this might sound like an elaborate science fiction story's plot, these types of discussions come up as simpler explanations fall short. In the meantime, the Vasco project is diligently scanning the universe, having only covered a small part of the sky so far. There is hope that this extensive space catalogue can be completed faster with the help of more volunteers and the development of new automated technologies. Vell hints at some major discoveries that are still confidential, which are expected to shake up the astronomy world once they are revealed. As the search continues, the team remains vigilant, ready to decode any peculiar patterns that might suggest something beyond our current scientific understanding. The quest not only pushes the boundaries of our knowledge, but also inspires a growing number of people to gaze up at the stars and wonder about the vast, enigmatic universe. Let's take a moment to think about the broader cosmic dance. Among the theories about stars that disappear, one stands out not because it ties to the alien activity, but because of its boldness. This theory proposes that what we might be seeing are the leftovers from ancient cosmic changes, echoes of the universe cooling down from its intensely hot beginning at the Big Bang. It suggests that as the universe grew larger and cooler, bubbles of space with lower energy formed. These bubbles collided and combined until they spread throughout the universe. Some physicists think that where these bubbles met, they might have created cosmic strings, defects in the structure of space-time, similar to cracks in ice on a lake. Oscar Hernandez from McGill University provides a comparison from our own planet to explain these cosmic phenomena. Imagine a lake freezing over. As the water molecules slow down, they lock into a solid, crystalline form, creating ice. This ice, though firm, can have cracks and splits in it. These are like the cosmic strings that might be the leftover traces of dramatic changes in the universe's structure. If these cosmic strings really exist, they could potentially be seen as unusual patterns in the cosmic microwave background, the faint glow left from the Big Bang. However, telling these patterns apart from the normal background noise is incredibly challenging. These cosmic strings, if they exist, are a fascinating glimpse into the dynamic history of our universe. They suggest that just as ice forms cracks when it freezes, the universe may have formed similar structural flaws during its dramatic cooling process. Understanding these could help scientists learn more about the Big Bang and the evolution of the universe. The search for evidence of cosmic strings involves looking for specific patterns or irregularities in the cosmic microwave background, the oldest light in the universe, which is a snapshot of the cosmos from just after the Big Bang. Each star that vanishes could lead us to an incredible discovery or could just be misleading us. The possibility that we might find entirely new aspects of physics, phenomena that challenge our understanding of the universe, is incredibly exciting. Yet, as we stand on the edge of the unknown, we have to wonder, are we observing signs left by cosmic architects, the remnants of ancient events in the universe? Or are we just seeing illusions in the vast emptiness of space? The path to these answers is filled with just as much chance for amazing discoveries as it is for errors. Each investigation into these vanishing stars not only pushes the boundaries of our current scientific knowledge, but also tests our theories about the universe. Are these stars' disappearances natural occurrences, or could they be evidence of something more profound? As researchers, it's essential to maintain a balance of curiosity and skepticism to navigate this complex terrain. Let's explore cosmic strings and how they could help us unlock the dark corners of space. The disappearing strings, hiding in space. As we delve into the depths of the cosmos in search of the elusive cosmic strings, we find ourselves entangled in the complex interplay of physics and astrophysics, often uncovering more questions than answers. Consider the challenge of trying to tile a vast lake from different shores simultaneously. Inevitably, some tiles will not line up perfectly. In a similar vein, cosmic strings are believed to originate from misalignments that occurred during the universe's phase transitions. These strings are envisioned as long cracks in the fabric of space-time, marking the spots where the universe settled into different states of matter in various regions as it cooled from its hot, energetic start. Researchers suggest that during these early cosmic transitions, the fundamental forces and particles were shaped by fields that emerged. The prevailing theory posits that a field might choose a specific orientation to freeze and cool in different parts of the expansive universe. Should these fields align in just the right way, they could leave behind lines of energy, echoes of discontinuity, similar to the theorized cosmic strings, narrow, energy-filled lines that stretch across the cosmos, resembling the theoretical scars left by the universe's dramatic cooling. This exploration into cosmic strings and the conditions of the early universe is akin to piecing together a cosmic puzzle. These theoretical strings represent the remnants of a time when the universe underwent dramatic changes that could potentially offer insights into the structure of everything we see around us. As the universe transitioned from a hot, dense state to its current cooled state, it didn't do so uniformly. Different areas cooled at slightly different rates or under different conditions, leading to these theoretical imperfections or cosmic strings. If these cosmic strings exist, they could tell us a lot about the forces that shaped the universe. They might act as cosmic relics that give us clues about the kinds of conditions that existed in the very early universe. Visualizing these strings as energy-laden lines crisscrossing the cosmos, we can imagine them as the stitching that bind the fabric of space-time. The idea that our current understanding of physics might only represent a small section of a much broader and more complex narrative is highlighted by these concepts. The current pinnacle of our knowledge in physics, known as the Standard Model, includes everything from quarks to electrons, as well as more unusual particles like the Higgs boson and neutrinos. However, this model is widely recognized as not being completely sufficient. Advanced theories like supersymmetry and superstring theory, which suggest that particles and forces are the vibrations of tiny, multi-dimensional strings, propose that cosmic strings are natural outcomes of the universe expanding rapidly after the Big Bang. The challenge to find these cosmic strings in the cosmic microwave background has become a critical goal for astrophysicists. A researcher named Hernandez from McGill University has pointed out the significant theoretical value of these strings, stating that finding them could either validate a range of theoretical models or completely overturn them. The task of actually detecting such elusive phenomena is extremely challenging. In a hopeful study conducted in 2017, Hernandez and his team suggested using neural networks that recognize patterns to identify these strings in the cosmic microwave background. Despite their efforts, the requirement for a completely clear, noise-free map of the cosmic microwave background to achieve this detection remains highly unlikely. This is due to the overwhelming presence of brighter microwave sources that obscure the faint signals of cosmic strings. The latest research results are quite revealing. Modern instruments designed to measure microwaves face significant challenges in terms of resolution and accuracy. These devices often encounter random fluctuations that disrupt the clearness needed to identify cosmic strings. The unavoidable noise and loss of data during the collection process make the traditional techniques for detecting cosmic strings almost useless. However, as often happens in the field of science, when one opportunity seems lost, another possibility emerges. The emerging method is known as intensity mapping. This technique doesn't focus on studying individual galaxies or creating detailed images of the cosmic microwave background. Instead, it involves measuring the average speed at which hydrogen atoms are moving away from Earth over large areas of space. It takes advantage of the unique 8.3-inch wavelength of hydrogen's electromagnetic radiation. Although observatories equipped to perform this type of mapping are not yet in operation, the potential of this new approach provides a ray of hope. Intensity mapping could revolutionize our ability to understand the universe on a grand scale. By bypassing the need for pinpoint precision in small areas, this method allows scientists to gather data over expansive regions, offering a broader view of cosmic phenomena. This could potentially reveal patterns or anomalies that are difficult to detect through more focused techniques. Even though the technology required to fully implement this method is still under development, the anticipation of its capabilities fuels optimism in the scientific community. The search for cosmic strings is a perfect example of the wider effort in science, constantly stretching into the unknown, seeking answers, and sometimes uncovering even more questions. As scientists press on with this search, there is a general feeling of cautious hope within the scientific community, with everyone prepared to switch directions and try new ways of finding answers. In the hunt for cosmic strings, as with all areas of science, each unsuccessful experiment and every path that leads nowhere actually contributes another small piece to the puzzle. This ongoing endeavor deepens our understanding and inspires new strategies when old ones prove inadequate. Every obstacle and setback faced in these scientific investigations teaches us something valuable, pushing the boundaries of our knowledge and our capabilities. It's a process of continuous learning and adaptation, where every bit of new information, whether it confirms our theories or disproves them, is valuable. Are these just natural phenomena, or could they hint at new undiscovered forces at play? What do you think? Don't forget to like and subscribe for more deep dives into cosmic puzzles.